Hi everybody, this is Dr. Sabayan again, and we're back to another discussion regarding files. So, as you can see here, some of the learning objectives that we're going to talk about would be how to use file input and output, how to use loops to process the file, using files on arrays, processing, some records, control break logic, and some of the other examples that we use. That will focus on Python and C++. So first things first, I apologize for my voice. I've been recording a lot of videos, as you can see, to supplement our discussion. But one of the most famous sayings among computer programmers is garbage in, garbage out, right? So this saying sometimes abbreviated as GIGO or GIGO, and it refers to the fact that computers cannot tell the difference between good data and bad data. So if a user provides for bad data as an input for the program will process that bad data, and as a result, it will produce for a bad data as an output. So when a program needs to save data for later use, it writes the data in a file and it can be used later. So most of the files and file input and output that we use nowadays would be for some word processors, your image editors, your Excel spreadsheets, the games that you have, the web browser. So those are just, um, some examples. Now there are three steps on how must take place for file interaction. First is you need to access the file, so that means you need to create it and prepare it for output. Second is you need to read data from the file, so you need to process the file. Lastly, you need to close the file to disconnect that one from the program itself. Now, some types of files include text and binary, and these are just examples for that. Moving forward, there are two methods on how files can be accessed. The first one will be sequential. That means the data is accessed from the beginning to the end, and all the data must be read. So, meaning to say, data is, on a chronological order. So, for you to be able to go to number 10, you need to access number 9 first. So, just to give you a quick example for that, let's say back in the days, let's say the cassette tape player, right? I mean, that's like 10, 15, 20 years ago, where you can't go for, let's say, song number 10. You need to go through the song 1 until song 9 to be able to, go to song number 10. So you need to access the data files from the beginning to the end. But nowadays we're using direct access. So this means that you can't access any data without reading the data that comes before or after that. So um, this chapter will focus more for the sequential access. Okay. Um, these are the processes on how to create a file and writing data to it. So the .dat extension that you see in this slide represents for general data. Okay. And then second, you need to create an internal name that is similar to a variable name. So in here, notice on this line, declare output file customer file. So we're in the output file. If this is the mode in which the file will be used, typically if something that you want to display, you put that one as an output file mode. Now, customer file is the internal name used to work with the file itself. So think about it as, a folder, okay? Next is the files must be open. So for you to be able to, access what's inside, you need to have the command open customer file, and then inside of that, access that, data, which is customers.dat. Fourth is you can actually write, or you could actually save, let's say a specific name in here, child space. I'm going to write that one or save it into a customer file. Now I also want to, let's say, have Charles space as a string name, and I'm declaring that as a string data type, and then write customer file name. Okay, so that means you're putting this Charles space inside of that variable. And then lastly, you need to close the file. Now, when we talk about files in general, there will be delimiters that you would encounter, for this chapter, which is regarding delimiters and EOF marker. Now, what are those? Now, delimiters are actually a set of characters, right? They're a set of characters that, marks the end of each piece of the data. Now, it is a, it's the purpose of this is to separate the different items that are stored in a file. So the exact character or set of characters that are used as a delimiter varies from system to system. EOF, on the other hand, is to indicate where the file's contents end. So the character that is used as an EOF marker, they also vary from different systems. Okay. Now, how do we read data from a file? Okay. So when reading data from a file, you must first declare an internal name that you will use to reference the file. So in this example, we're using declare input inventory file, where input file indicates the mode in which we will use in the file. Okay? Input file indicates that we will be reading data from the file. Second one, the name inventory file is the internal name we will use to work with the output file in our code. Okay. Next one, you need to open it. So that's just a command that we use, open inventory file. So again, inventory file, this would be the internal name that we use. It's like, hey, as if you're saying that I am going to have this one inside of this folder. Next is we're going to read the data. Once you have opened the input file, you can read data from it. So on the pseudocode that we have, we will use read statement to read a piece of data, um, inventory file, and the item name inside. Okay. Now, lastly, you need to finally close your file. So that's somehow an introduction for your input and your output. Okay. Moving forward, when we say append or appending data to an existing file, most of the programming languages, when you open an output file and a file within the specified external name exists, the existing file will be erased and a new file with the same name will be created. So sometimes you want to preserve an existing file and append the new data to the current content. So appending data to file, meaning to say you're writing new data to the end of the data that already exists in the file. So most languages allow you to open an output file using the append mode, and that means that if the file already exists, it won't be erased, but it will be created. Okay? When the data is written to the file, it will be written at the end of the file's current contents. So this is an example of a pseudocode on how to use the append mode as shown on my screen. Now you can also use loops to process a file, although some programs use files to store only small data, but files are typically used to hold large collections of data. So when a program uses a file to write or read a large amount, a loop is typically involved. So this is an example on how we can use the loop to be able to read large amounts of data. Okay, now how are we going to use files and arrays for that? Okay, so having what's that, files and arrays, you can actually use that together. The contents of an array can be saved to a file, and you need to have a loop through each of the element of the array before you can actually put contents on that file on each of that iteration. Now, how do you process? So how do we process records? So first thing is, what is a record, right? The data that is stored in a file is frequently organized in records, and it's a complete set of data about an item. A field is an individual piece of data within a record. So when data is written to a file, it is organized into records and fields. Okay, so for this figure dash 10, you would be able to see that one record in here contains different fields on it, such as Ingrid Virgo 4587 for the ID number field and engineering for the department field. Now, in the pseudocode given on this screen, we're going to write and enter record using a write statement. So, for example, assume that the variables are um, name, ID, or department, and that it contains all the files regarding that employee file. Okay, employee file is the file we're going to write the data to. So let's say write employee file name, ID number, and department. So if you are done with that, you need to write it, and then here comes reading the file. Okay, uh, pretty much the same format for that. Now, what is a control break logic? Okay, control break logic is actually very important because in this example, as you can see, if there would be some task, ongoing task, let's say the program will perform ongoing task and it's interrupted, the task when a control variable changes its value. Now, when this happens, some other action is performed and that the program resumes on that ongoing task. So pretty much when we say control what's that control break logic, when you're interrupting the processing of an existing task. Okay, now assume that the file contains the following data organized by state. As you can see in here, our task is to produce a sales report using the total sales for each day. Okay, now this program will read the records keeping a total of the sales amount. And if you can notice that when the program um, changed the state, it will print the total and then reset the total to 0. And then after that, it will continue to go on and process until there are no more other records that are accessed. So this report looks just like so. Okay, now that's the end of our discussion. I'm going to provide for other examples as well, and please check the discussion board or the lesson discussion, and check the due dates for some of your homework. So until next video, you have a great day ahead.